We will practice proving trig identities. Prove these identities or provide a counterexample. So first we can use graphing technology to check if it is an identity or if it is not. What will happen when we graph this? We'll graph the left side and the right side separately. If this is an identity, they should be the same graph. If it is not an identity, then they will look different. So I already typed the equations in. Sine 2x on the left side, 2 cos squared x over sine on the right side, and they're not equal. There are some points where they intersect. So there are some x values where these are equal. But for it to be an identity, it would have to be equal everywhere in the entire domain. So it is not equal. Let's provide a counterexample. What's a value where it fails? So we need a value where it fails. Let x equal 0. We're going to show the left side and the right side separately. So we sub in our value of 0. Sine of 0 is equal to 0. Let's do the right side. Again, x equals 0. We want to sub in the same value for both sides. Cos of 0 is equal to 1. Sine of 0 is equal to 0. Now if we try to simplify this, can we divide by 0? No. So this side is undefined. So we can conclude the left side is not equal to the right side, so it's not an identity. Now let's work on part B. Cosecant x over 2 cos x equals cosecant 2x. First thing we're going to do is verify by graphing. There's one part. There's the other part. Wait a second. What happened there? Oh, they're equal. Great. So we can prove this one. Okay, so some advice. We look on the left side, we look on the right side. How are they different? How are they the same? It helps if you try to always get the same trig function. So right now we have cosecant, which is 1 over sine x, and we have cos. It helps if we get everything in terms of cos and sine, and after that we might need to do some more adjustments. So first we're going to work on the left side. So cosecant x is equal to 1 over sine x, and that's divided by 2 cos x. So you could do a few more steps if you need to prove it to yourself, but what we have, cos x is in the denominator, and this is what we have. Can't really go any further with this right now. You could look at your formula sheet. Does this remind you of any of the trig identities that we have? Any compound angle formulas, Pythagorean? But if you're stuck here, then you can start working on the right side. At this point, we can look, the right side has a double angle, where the left side only has single angles. So you know you need to get rid of your double angle. So if you look at your formula sheet, or if you remember all of your trig identities really well, you'll know that sine 2x is equal to 2 sine x cos x. And of course now the right side is equal to the left side. We've just proved this trig identity. So since the left side is equal to the right side, therefore cosecant x over 2 cos x equals cosecant 2x. Done. QED. Sometimes people write a QED or a little square. That means end of proof. Completed. Well done. Continue to practice. The more you practice trig identities, the more comfortable you'll get with them. It's all about doing substitutions and simplifications, looking on the left side and the right side and getting them to match up. But remember, maybe it's not equal. You could always graph to make sure it's equal if you're feeling very stuck. Good luck.